Myself K. Lakshmi, Assistant Professor of Narasimha Reddy Engineering College. Today's topic is methods of interstage coupling. I am going to teach you about interstage coupling. So already, like in the previous video, I taught you different types of coupling stages. They are nothing but RC coupled, transformer coupled and direct coupled. So let us see one by one their functioning and applications. Methods of interstage coupling. In multi-stage amplifier, the output signal of preceding stage is to be coupled to the input circuit of succeeding stage. So the previous stage output is connected as input to the next stage. For this interstage coupling, different types of coupling elements can be used. These are RC coupling, transformer coupling and direct coupling. So first circuit is two-stage RC coupled amplifier using transistor. This is nothing but RC coupled amplifier. So two single stage CE amplifiers are connected side by side, forming the cascaded amplifier. Okay, it is known as multi-stage amplifier. So already you know the functioning of each CE amplifier circuit. R1, R2 forms the potential divider network. RE forms the stabilization of Q point. CC, that is capacitors in the circuit, are act as coupling capacitors. CE in the circuit act as emitter bypass capacitor, provides low reactance path. So input is given at base of the first stage and the output will be taken at the collector of the last stage. Here the last stage is nothing but second stage. So VCC will be provided biasing for both the transistors. Okay, here frequency response, let us see its functioning. The output signal of first stage is coupled to the input of the next stage through coupling capacitor and resistive load of the output terminal of first stage. The coupling does not affect the Q point of the second stage as CC blocks DC voltage of first stage. If you see both the stages, so the output signal is coming from the first stage through the coupling capacitor. So with that it will not change the Q point of the second point. Suppose if DC allows into the second stage, then the position of the Q point means DC point for the second stage will be disturbed. So this amplifier gives wideband frequency response without any peak at any frequency and hence used to cover a complete audio frequency amplifier bands. So therefore it doesn't give any peak like over a band of frequencies. Therefore it is used as like audio amplifier. Is used as an audio amplifier. So let us see later its frequency response. The next one is transformer coupled amplifier. So in transformer coupled amplifier, so actually here there are two stages. So first stage is connected to means its input is connected at the base of the first transistor through the transformer. Similarly, the output of the transformer is connected to the input through the transformer. Therefore it is known as transformer coupled amplifier. Okay, it provides good impedance matching. So this type of coupling is used to match the impedances between output and input cascaded stages. We know that transformer blocks DC and allows AC. Therefore it also does not affect the output of first stage, also does not affect the Q point of the second stage. Okay. Next, what are the advantages of transformer coupled amplifier? So it provides excellent impedance matching. Like it provides high power amplification. What are the disadvantages? Transformers are using, therefore transformers are costly. Next, frequency response is poor. So that these are nothing but disadvantages of transformer coupled amplifier. So next, coming to direct coupled amplifier. So in direct coupled amplifier, so if you see there are no coupling capacitors, therefore the output of first transistor is connected directly to the input of the second transistor. Therefore DC point will be added to the second stage. Therefore Q point will be disturbed for the second stage. It is a serious problem in direct coupled amplifier. Okay, so whatever change appears at its input of the second stage, that change will appear at the output of the second stage. This is known as drift problem, serious like a drift problem. Therefore there will be the drift problem in direct coupled amplifier. So now let us see the frequency response of RC coupled amplifier. So if you see over a band of frequencies, actually frequency response is nothing but it is a graph between frequency versus voltage gain. So frequency on x-axis and voltage gain on y-axis. So over a band of frequencies there is no peak, therefore the line is horizontal. So that is why it is known as like a good audio amplifier. It is also known as voltage amplifier. Okay, so if you see the graph, there is the gain fall in the low frequencies, similarly gain fall in the high frequencies. In the low frequencies gain is decreasing due to like external capacitors present in the circuit. What are the external capacitors? CB, CC and CE. So here if you see at high frequency gain is falling due to internal capacitors of the transistor. What are the internal capacitors? There are two shunt capacitances. They are nothing but CBE and CBC. Due to these capacitors gain is falling at high frequency. Similarly, if we see like a transformer coupled amplifier, there will be peak in over a band of frequency. It is due to transformer present in the transformer coupled amplifier. So therefore the frequency response is not as good. In direct coupled amplifier there will be no gain fall in low frequency. So therefore it is used as for the amplification of low frequencies. It is mostly suitable for low current amplification. Now let us compare like three coupling elements or three coupling amplifiers. So first one is RC coupled, transformer coupled, direct coupled. So what are the coupling components in RC coupled? Resistor and capacitor. What are the coupling element in transformer? Impedance matching transformer. Direct coupled, there are no coupling elements. So in RC coupled amplifier DC will be blocked, in transformer coupled DC will be blocked, whereas in direct coupled DC component will not be blocked. Frequency response flat at middle frequencies, not uniform, high at resonant frequency and low at other frequencies. Okay, here gain is falling in low frequency due to external capacitors, whereas at high frequency due to interwinding capacitance between the transformer. Okay, in direct coupled flat and middle frequencies and improvement in the low frequency response. Okay, in high frequency like in direct coupled it is falling due to internal capacitances. Impedance matching not achieved in RC coupled, so good like impedance matching in direct coupled also not achieved. DC amplification in RC coupled amplifier no, in transformer coupled no, whereas in direct coupled amplifier DC amplification will be possible. Weight RC coupled amplifier is light, transformer bulky and heavy. Okay, this is very least direct coupled. Drift not present in RC coupled, not present in transformer. So drift will be there in direct coupled because Q point depends on the temperature. If temperature changes, Q point changes. That is known as drift problem. Hum not present, present not present. That means in RC coupled amplifier noise not present, in transformer coupled noise will be present, in direct coupled noise is present. Application used in all audio small signal amplifiers, used in record players, tape recorders, public address system, radio receivers and television receivers. Used in amplifiers where impedance matching is required, used in the output stage of public address system to match the impedance of loudspeaker, used in RF amplifier stage in the receiver as a tuned voltage amplifier. So used in amplification of slow varying parameters and where DC amplification is required. So wherever DC amplification is required, therefore which coupling circuit will be used? Direct coupled circuit will be used. Now let us move to the, just now like I have explained you cascaded amplifier. So this is nothing but circuit of cascaded amplifier. This is two stages of CE amplifiers. Okay, analysis, we should analyze, we should start the analysis with the second stage. So here H parameter equivalent circuit for CE cascade amplifier. First replace the second transistor with H parameter model. Next first transistor with H parameter model. Start from the second stage, then find out the parameters like AI, AV, RI and R0. Next, coming to cascade amplifier. So cascade amplifier is the combination of CE and CB amplifiers. First stage is nothing but CE and the second stage is nothing but CB amplifier. So actually using cascade amplifier we can solve the low impedance problem of CB circuit. So cascade amplifier gives high input impedance of CE amplifier as well as good voltage gain and high frequency performance of CB circuit. So only drawback in this is poor frequency response. Okay, you follow the same steps what I told you for a single stage amplifier for the analysis, then find out parameters like AI, AV, RI and R0. Okay, next, see this is the equivalent circuit. So equivalent following, what are the following steps to be followed? Like short the coupling capacitors, short the VCC, that is make it ground, replace the transistor with H parameter model. Okay, so after replacing with its H parameter model, this is the equivalent circuit as shown in figure. So here Ri is nothing but input resistance of the transistor, Ri prime is overall input resistance, R0 is the output resistance, R0 prime is the overall output resistance. So this is the simplification of H parameter model. Okay. So when output is shorted, this is the circuit. So here when output is shorted, this is when current is shorted, that is IB equal to 0. So next combination is CE-CC amplifier. So analysis for the first stage. Okay, start with the second stage in the same way how we analyze. Next, Darlington transistors. Actually I told you like in Darlington transistor, if we take single stage CC amplifier with a biasing resistor, the input resistance is reduced. So to overcome this problem, we have two techniques known as direct coupling. Direct coupling is nothing but Darlington transistors or Darlington connection, and the second technique is bootstrap. Okay, in Darlington you can see the output of first stage, that is emitter, is given as input to the second stage. Second stage input is base. Okay, and output will be taken at the emitter of the second stage. So start the analysis from the second stage as shown in figure. So this is how you will find out the input resistance current gain. So we can like compare single stage and Darlington. So what is the Ri? 1 plus HFE into Ra. So here how much you are getting if you substitute 168.3 kilo ohms. Here 1.65 mega ohms. Therefore that much input impedance is increased with Darlington. AV is approximately equal to 51. Here AI equal to 51. Here AI equal to 500, means current gain is also increased. Next, second technique is bootstrap emitter follower. This is another technique to improve the input impedance of a single stage CC amplifier. So here you can observe there is the the C is connected in between the emitter terminal and the junction of R1, R3 and R2 resistors. Okay, therefore since it is C is in between, means you have to follow the steps, no. C will be shorted. When C will be shorted, directly this R3 will be directly connected, where this R3 will be connected directly to RE, as here R1, R2, here R1, see, when C is connected, this R2 is connected, R1 and R2 will be connected at the output side. See, R1 and R2 are shown in figure. Bootstrapped Darlington circuit. So this is another circuit to obtain input impedance of more input impedance. So AC equivalent circuit for bootstrapped Darlington. So after replacing with its AC equivalent, so these are the circuits shown in figure. Bootstrapped Darlington circuit alternate approach. Okay, so this is another way to find out current gain, voltage gain, input resistance and output resistance. So when capacitor is shorted and this will be connected, actually directly will be connected to where? So here R1 and R2, and last one is what? RM2, and this is RM1. Why RM2, RN1? So this is R2 will be R3 forms the feedback, no? So therefore using Miller's theorem, it should be connected across the input and across the output as RM1 and RM2. So frequency response of an RC coupled amplifier, already I have explained you. If you see the frequency response, here actually in this mid frequency region, the graph is very flat. That means it is best used as an audio amplifier. So below this low frequency, it has three regions: low frequency region, mid frequency region and high frequency region. So the dotted line represents the ideally frequency response and the solid line represents the practical frequency response. So here half power frequencies and bandwidth of an RC coupled amplifier is as shown in figure. So F1 and F2 are represented where gain falls to 70.70% of 7% of its mid-band gain. So at mid-band gain is denoted by AV mid, and the 70% gain is denoted as 0.70 AV mid. So this is about interstage coupling.